Hello everyone! So for today, pag-uusapan natin yung definite integrals. So let's start. So let's consider a function f of x, which is this pink one here, and the region R bounded above by f of x and bounded below by the x-axis. Ang gusto nating gawin is i-identify kung ano yung area under this curve. So kung simple lang naman siya na function, like let's say this line, madali lang naman natin makukuha yung area nito since existing na yung formula niya. So that's just base times height over 2. Or kung yung curve naman natin, let's say is a semicircle, madali lang din natin makukuha yung area nito. That's just pi r squared. Pero since semicircle siya, we divide it by 2. However, paano kung nagko-consider tayo ng arbitrary na curve? For example, yung curve natin is pa ganito. How can we obtain yung area under that curve? So, ang naisip ng mga mathematicians from way before is hatiin yung ating x-axis into several partitions. So, tawag natin dito ay partitions. Then after that, pumili sila ng isang point sa loob ng partition na yon and hinanap yung katumbas na f of x. So, for example, you have here x sub I star. So, hahanapin natin yung f of x sub I star. Then after that, kinonstruct nila yung rectangle with base na delta x sub I, which is yung length ng partition. Tapos yung height niya is yung function value at xi star. So sabi nila, yung area daw under that curve is approximately yung sum ng area ng bawat rectangle. So from the picture itself, nakikita naman natin siya. So for example, for this first rectangle, makikita natin meron siyang na-cover dito na part na nasa taas ng graph. Tapos meron siya dito na hindi na-cover. Same for the other rectangles. Na-cover niya to, pero this one di niya na-cover. Tapos ito hindi niya na-cover, pero this one sumobra siya. So, what can we do para mas maging accurate yung ating pagkuha ng area? So, sabi nila, if you choose daw smaller partitions, so kuha ka na mas marami pero mas may ikli na partitions, in the end, mas magiging accurate yung ating pagkuha ng area using the rectangle. Since what happens, mas marami kang points ngayon na pinagbabasihan. So for example, this one, tapos this one, tapos kunin natin to, kunwari, we can see kung gumamit tayo ng tatlong rectangles, mas accurate na yung pagkuha natin ng area. So, sabi nila, if we let the number of partitions approach to positive infinity, tong sum na to, f of xi star times delta x sub I from I equals 1 to n is equal na raw do sa mismong area ng ating curve. And tong area na to is what we call the definite integral of f from a to b. So, kung tatandaan natin before, yung sa derivatives give us an insight about the slope of the tangent line ng isang curve. But this time, by defining the definite integral, we can now think of our integrals. So, yung mga integrals daw natin, basically, pwede natin siyang isipin as the area under the curve. Area under the curve. So, basically, that's definite integral. So, definite integral, kinukuha mo lang yung area sa ilalim ni f of x, but above the x-axis from x equals a to x equals b. Then, some terminologies lang. A function f on an interval a to b is integrable if the integral daw from a to b of f of x dx is less than infinity. So basically, sinasabi niya, integrable daw yung function f within an interval kung yung magre-result na definite integral is a number and not positive infinity or negative infinity. And as a theorem, we have these implications. So, sabi natin before, if a function f is differentiable, then f is also continuous. Pero ngayon, pwede na natin siyang dagdagan. If a function f is continuous, then the function f is also integrable. So, kung i-visualize natin siya, suppose ito yung set ng lahat ng functions which are differentiable. So, set of differentiable functions. Ito raw ay nasa loob ng set of continuous functions. Tapos, yung set of continuous functions ay nasa loob ng set of integrable functions. So, kung makakita ka ng isang continuous function, automatically, integrable siya. However, if integrable yung isang function, it doesn't mean na continuous agad yung function na yun. For Math 21, I don't think na makaka-encounter tayo ng such functions na integrable but not continuous. However, if you go to advanced calculus, marami ng examples nun. So, sabi natin, geometrically definite integral is just the area under the curve. However, we are considering na yung ating area is above the x-axis. Paano naman kung yung graph natin tumatawid siya sa ilalim ng x-axis? So, we have a different interpretation now for the definite integral. So, tinatawag natin siya na net signed area. So, pag sinabi natin net signed area, kinukuha natin yung area ng mga stuff above x-axis. So, ito yun. Then, sinusubtract natin yung mga area below the x-axis. So, for example, ito yung function f from A to B. Tapos, we have identified three regions here, R1 and R3, na above the x-axis. Tapos, yung R2 is below the x-axis. So, yung integral daw ng f of x dx from A to B is yung area sa region 1 minus yung area sa region 2 since nasa baba siya plus the area of region 3. So, ganun natin kinukuha yung net signed area. Kunin nyo lang yung mga nasa taas, then isubtract nyo lahat nung nasa baba. Then, here are some properties of the definite integral. So, suppose f and g are integrable on this closed interval AB. First one, yung integral daw ng f of x dx from A to B is just the same as the negative ng integral of f of x from B to A. So, sinasabi niya, kung pagbabaligtarin daw natin yung bounds ng integration, we need to have here a negative sign. Pangalawa, the integral of f of x dx from A to A is equal to 0. So, paano yung visualization nito? Suppose this is the function f, tapos piliin natin to as x equals A. So, sinasabi niya, yung area daw exactly at this point is just 0. Since yung length natin dito is 0, then yung height is some number, say c. So, c times 0 is just 0. Number 3, yung integral daw of c dx from A to B is c times b minus a. So, what we have here is a constant, c, and gusto daw natin kunin yung area niya under the curve. So, let's choose this one. Kung wari, ito yung f of x equals c. Tapos, ito yung x equals a, x equals b. So, obviously, what we have here is a rectangle. So, yung area nito is length. So, that's b minus a times height, which is c. So, we have c times b minus a. Yung fourth and fifth, these are just the properties that we have from our indefinite integrals before. So, number 4, sinasabi niya, kung meron kang constant na nakamultiply sa isang function, pwede mong ilabas. Tapos yung panglima, if you have functions na separated by plus and minus, pwede mo silang ipaghiwalay. So, that's number 4 and number 5. Number 6, so medyo mahaba yung sinasabi niya. Suppose daw that you have an integrable function f on a closed interval I containing the three numbers a, b, and c. Then, what you can do, kung nagko-compute ka ng integral of f of x from a to b, pwede mo raw silang split by introducing a new number c. So that becomes the integral of f of x from a to c plus the integral of f of x from c to b. So, kung ito si A, tapos ito si B, tapos kunwari dito si C, kung kukunin mo yung area from A to B, pwede mong gawin, kunin mo muna tong area na to, A to C, tapos i-add mo na lang yung area nito, C to B. So, yun yung sinasabi ng number 6. So, let's have one example. If the integral of f of x dx from negative 2 to 7 equals 12, tapos integral of f of x dx from 3 to 7 equals 4, and integral from negative 2 to 3 of g of x equals 5, let's find this integral. So, integral of 5 f of x minus 4 g of x as x goes from negative 2 to 3. So, let's apply first the properties to this one para mas clear sa atin kung ano yung mga kailangan natin. Wait, ba't ayaw nung pen? So, apply natin yung properties dito, no? So, what we have is integral from negative 2 to 3 of 5 f of x minus 4 g of x dx. So, first thing na makikita natin, we have two functions here na separated by a minus sign. So, pwede nating split yung integral. So, we have here integral from negative 2 to 3 of 5 f of x dx minus integral of negative 2 to 3 of 4 g of x dx. Then, makikita natin dito, merong constants na nakamultiply sa function natin. So, dito, merong 5 na pwede nating ilabas. Then, tong 4, pwede rin nating ilabas. So, to save space, ilabas ko na siya agad. Oops. Ayan. So, it becomes 5 integral from negative 2 to 3 of f of x dx minus 4 times the integral of g of x from negative 2 to 3. This one is already given to us. Ito lang yun. However, wala tayong given about this integral. So, let's try and see what we have. So, given tayo integral of f of x from negative 2 to 7. Tapos, meron tayo integral of f of x from 3 to 7. So, let's try and visualize what is happening here. So, negative 2 to 7, ito si f. Tapos, yung 3 is somewhere between negative 2 and 7. Ang gusto nating makuhang area is yung area from negative 2 to 3. So, what we do is kunin natin yung area ng buong to, then remove natin tong area na to. So, what we have, integral of negative 2 to 3 f of x dx is just the integral from negative 2 to 7 of f of x dx. Tapos, isubtract natin yung area from 3 to 7. F of x dx. This one is 12. Tapos, this one is 4. So, 12 minus 4, we have here 8. So, going back to this one, this should be equal to 5 times integral of f of x from negative 2 to 3. So, that's 8 minus 4 times integral of g of x from negative 2 to 3, which is 5. So, 5 times 8 is 40 minus 4 times 5, that's 20. So, yung buong area is 20. I hope clear tong example na to sa atin. So, kung hindi siya clear, pause for a while and maybe rewind kung ano yung ginawa natin, or if it would help, try to resolve yung ginawa natin. So, the next part of our discussion is one of the most important results na pag-uusapan natin sa Math 21. So, this is the fundamental theorem of calculus. So, from the word itself, lahat ng pinag-aaralan natin sa calculus so far could boil down to this one because these are the most important results that we have. So, merong dalawang parts tong fundamental theorem of calculus, but isa-isahin natin siya para ma-digest natin siya. So, first one is the first fundamental theorem of calculus. Sinasabi nito, suppose that you have a function f which is continuous on this closed interval AB and let x be any number sa loob ng interval na to. If capital F of x is the integral of f of t dt from a to x, then the derivative of big F of x is just small f of x. So basically, ini-establish lang niya yung ating notion before na ang integral gives the antiderivative of a function. So basically, first fundamental theorem of calculus is telling us na derivatives and integrals, or should I say, para mas precise pala yung word, differentiation and integration are inverse operations. So, yan lang yung sinasabi ng first fundamental theorem of calculus. And later, pwede natin siyang gawin para kunin agad yung derivative ng function na ito without performing any integration, since they are just reverse operations. However, kung titingnan natin yung statement ng fundamental theorem of calculus, it is quite limited since we're requiring na yung upper bound is x. Pero paano kung yung upper bound natin is some sort of function, let's say g of x. So we have this corollary. So for the people here na hindi familiar sa kung ano yung corollary, so corollary, this is just a direct consequence of any theorem. So direct consequence of a theorem. So, as a consequence nung first fundamental theorem of calculus, if capital F of x equals the integral of f of t from a to g of x, where f is continuous dun sa closed interval na to, and g is any function na defined dun sa interval na to, then f prime of x equals f of g of x times g prime of x. So, if you want to see a proof of this one, I think nasa lecture video siya. Pero, dun sa notes na isa-send ko sa inyo, or kung napapanood nyo man to ngayon, probably nasend ko na yung notes. So, dun sa sinend kong notes, nandun siya. So, feel free to read that one. So, let's try and solve some examples. So, hanapin daw natin yung derivative of the following functions. So, first one, capital F of x equals the integral of t squared sine t dt from 0 to x. Ano raw yung integral nito? Ay, ano raw yung derivative nito, rather. So, derivative nito, kung titignan natin, 0 is a constant, tapos x is just x. So, pwede nating gamitin ng diretsuhan yung first fundamental theorem of calculus. So, f prime of x is just f of x. So, yung nasa loob na t squared dt, papalitan lang natin siya ng x. So, derivative nito is x squared sine of x. So, that's number 1. So, number 3, medyo mas marami siyang sinasabi sa atin. So, hanapin daw natin yung derivative ng function na to defined by the integral from 5 to 2x of the derivative of the integral of t square root of t cubed plus 1 from 1 to 3s squared. So, sa loob, meron tayong integral, tapos kukunin natin yung derivative niya. So, let's focus there first. Paano ba? We let g of x na lang, siguro. We let g of x to be equal to... sorry, but x... it shouldn't be x. G of s to be equal to the integral of 1 to 3s squared ng square root of t cubed plus 1 dt. So, bakit siya s? That's because kapag kukunin natin yung definite integral na to, tapos i-plug natin yung bounds, ang lalabas here is a function in terms of s. And later makikita nyo kung bakit in terms of s nga talaga siya. So, let's apply first directly yung ating corollary sa first fundamental theorem of calculus. So, once again, hindi applicable ang original version ng first fundamental theorem of calculus because yung nasa taas is a function of s. So, by the corollary, we have g prime of s to be equal to the square root of this one cubed. So, that's 3s squared cubed plus 1 multiplied by the derivative nung nasa taas, which is 6s. So now, what we have is f of x equals the integral from 5 to x of 6s square root of the quantity 3s squared raised to 3 plus 1 ds. And applicable ba yung first FTOC? So, nasa baba, we have a constant. Sa taas, 2x siya and not x. So, hindi uubra yung original form, but we can use the corollary. So, we have here f prime of x equals 6 times, log this one to s, 6 times 2x times the square root of the quantity 3 times this one squared. So, 3 times 2x squared raised to 3 plus 1 times yung derivative nito, which is 2. So, that's it for number 3. And that ends our discussion sa first fundamental theorem of calculus. So, kung gusto nyo mag-take ng break, you can take a break first. But before you do that, just as proof na nanood kayo nung video na to, please comment sa comment section a certain food boodle for me. Since kapag gusto kong mag-order ng food, pakikinggan ko na lang kung ano yung sinabi nyo. So, please comment down below kung ano man yung food boodle nyo for me. So, I assume tapos na kayong mag-break kung nag-break man kayo. So, let's proceed sa second fundamental theorem of calculus. So, this one actually gives us a way to compute the definite integral itself. So, let small f be a function continuous on this closed interval AB. If big F is any antiderivative of small f on this closed interval, then yung definite integral daw ni small f from a to b is equal dun sa capital F evaluated from x equals a to x equals b. Or basically, sinasabi nito, you just get the evaluation of capital F at x equals b, tapos isubtract mo yung evaluation ni capital F at x equals a. So, this one is just the indefinite integral itself. Pero, kukunin mo right after tong difference na to, f of b minus f of a. So, kung titignan natin, second fundamental theorem of calculus is actually quite limited because we are talking about a single function. However, if you recall, we discussed U substitution. So, what will happen if yung given na function sa atin is of this form? F of g of x times g prime of x. Luckily, meron tayong way para kunin yung ganong definite integrals. So, we have this corollary here. If f is a continuous function on this closed interval a to b, and u equals g of x is a differentiable function on that closed interval, then the integral of this one, f of g of x times g prime of x dx, is just the same as the integral of f of u from g of a to g of b. So, ano yung sinasabi sa atin ng corollary na to? So, if you will apply U substitution, so that is changing yung nasa loob, then kunin yung derivative para mapalitan yung nasa labas. Hindi enough na gawin yung substitution and palitan yung nasa labas. Since meron tayong bounds na kino-consider, you have to replace yung bounds na to. Since what we have na bounds here is in terms of x. However, pinalitan mo yung variable to u, which is g of x. So, you apply g dun sa ating bounds. So, let's have some examples. So, letter A, kunin natin yung integral of sin of x dx from 0 to pi over 2. So, ano ba yung integral muna ng sin of x dx? So, this should be familiar already sa inyo. Ang integral nito is negative of cosine of x. So, negative cosine x. However, since we're obtaining the definite integral from 0 to pi over 2, we have to evaluate this one from x equals 0 to pi over 2. So, we get here negative cosine of pi over 2 minus negative cosine of 0. And this is equal to, so cosine of pi over 2 is just 0. Tapos, cosine of 0 is 1, pero naka-negative siya, so that's minus negative 1. And 0 minus negative 1 is just equal to 1. So, simple lang siya, no? Kung kaya nating kunin agad yung mga integrals niya. So, kunin mo yung integral, tapos evaluate at x equals 0 and pi over 2. Then get their difference. But when getting their difference, start dun sa nasa taas, then minus yung evaluation sa baba. Okay, so let's proceed to letter B. So if you want to try this one out, please try this one first. So, let's try and solve this one. So, meron kang y sa labas, Tapos sa loob ng square root, you have y minus 1. And pagdating sa square roots, napaka-problematic ng mga plus and minus since hindi naman natin na-split yung square root kung ganun. So, what we do, we apply a u substitution para sumimple yung nasa square root. So, let u be equal to y minus 1. So, kung yung u natin is y minus 1, ano yung du natin? So, du natin is just the derivative of y minus 1, which is 1, multiplied by dy. So, du equals dy. Pero dahil nag-u substitution tayo, and we're obtaining the definite integral, kailangan din nating palitan yung bounds. So, if y equals 1, yung u natin is just 1 minus 1, which is 0. But if y equals 2, so ito yun, if y equals 2, yung u is 2 minus 1, which is 1. So, itong buong integral na to, integral from 0 to 1 of yung nasa loob, this will become the square root of u, tapos yung dy magiging du. Pero, paano si y? So, meron tayong y sa labas, no? Luckily, madali lang natin siya mapapalitan from here. So, if u equals y minus 1, if ilipat natin yung negative 1 sa left side, we get u plus 1 equals y. So, this one becomes u plus 1. And if we expand this one, we get here 0 to 1 of, so yung square root of u, this is just the same as u raised to 1 half. So u times u raised to 1 half would give us u raised to 3 halves. Tapos 1 times square root of u is u raised to 1 half. So that becomes u raised to 3 over 2 plus u raised to 1 over 2 du. Okay. And kaya na ba natin kunin yung integral nito? So what we have is a variable raised to a power na hindi equal sa 1. So pwede natin gamitin yung power rule. So this one becomes u raised to 3 halves plus 1, which is 5 halves, all over 3 over 2 plus 1, which is 5 halves, plus u raised to 1 half plus 1, which is 3 over 2, all over 1 half plus 1, which is 3 over 2. Then evaluated from u equals 0 to u equals 1. So, evaluation nito, napakasimple na lang naman na for us. So, let's start with u equals 1. Magkakaroon tayo here ng 1 raised to 5 halves over 5 halves plus 1 raised to 3 halves over 3 halves minus, so if i-plug natin yung 0, 0 na to, 0 na to, so that's 0 plus 0. This one here, 1 raised to 5 halves, is just 1. This one is also 1. So, 1 over 5 halves, since may fraction ka sa baba, pwede mong kunin yung reciprocal nito. So, we get here 2 over 5. Then, para dun sa isa, that's just 2 over 3. Then, simplifying, so, common multiple nila is 15. Tapos, 15 over 5 is 3 times 2 is 6. Tapos, 15 over 3 is 5 times 2 is 10. And this one gives us 16 over 15. I hope clear sa inyo kung paano nakuha tong letter B. So, if clear na ang lahat, let's proceed to letter C. Oh my. So, sa letter C, we have here an absolute value, and wala pa tayo na-encounter, no, na absolute value ever since pinag-usapan natin ng integration. So, paano kaya natin pwedeng kunin yung integral ng absolute values? So, safest thing to do is gamitin natin yung definition ng absolute value. So, we take note na yung absolute value of x plus 1 is equal to itself if x plus 1 is greater than or equal to 0. Pero if tong nasa loob is negative, kinukuha natin yung negative niya. So, negative of x plus 1 if x plus 1 is less than 0. Then, solving for x dito, ilipat lang natin yung 1. So, we get here x greater than or equal to negative 1. X is less than negative 1. So, ano yung sinasabi sa atin nitong definition ni absolute value of x plus 1? So, sinasabi niya, if nasa right daw tayo ni x equals negative 1, we take f of x equals x plus 1. So, ito yung negative 1. Pero, kung nasa right daw tayo, we take the negative of x plus 1. So, let's see yung bounds na integration. So, bounds natin is negative 2 to 2. So, yung negative 2 nasa kaliwa siya ni negative 1. Tapos, si positive 2 ay nasa kanan. So, basically, yung function na yan could be divided into 2. So, first, kunin natin yung integral from negative 2 to negative 1. And ang gagamitin nating version is this one, the negative of x plus 1. Pero, kapag nasa negative 1 to 2 tayo, ang gamitin natin is yung positive, which is x plus 1. So, the entire integral becomes integral from negative 2 to negative 1 of negative of x plus 1 dx plus the integral from negative 1 to 2 of x plus 1 dx. Meron pang constant dito na negative, so pwede natin siyang ilabas. So, literal na ilalabas ko siya ngayon. So, pwede ko na siyang gawin ngayon since wala naman tayo sa blackboard. So, literal na nilabas ko siya. So, let's compute for the integrals of the following. So, for the first one, integral of x plus 1, that's x squared over 2. So, x raised to 1 plus 1 all over 1 plus 1. Plus integral of 1 is x, and this is evaluated at x equals negative 2 to x equals negative 1. Then para dun sa kabila, same lang din, no, yung integral niya, that's also x squared over 2 plus x, pero we're evaluating from x equals negative 1 to x equals 2. So, ito na yung medyo madugong part since mahaba-habang computation na to. So, starting from the first one, we have here, una is yung evaluated at negative 1. So, that's negative 1 raised to 2 all over 2 plus negative 1 minus this one evaluated at x equals negative 2. So, that's negative 2 squared all over 2 plus negative 2. Okay. Ayan. Tapos, square bracket. Plus, for the other integral, we have here, starting with x equals 2. So, this is 2 squared all over 2 plus 2, tapos minus, at x equals negative 1, that's negative 1 squared over 2 minus negative 1. So, iwan ko na sa inyo yung pag-evaluate nito. Pero for the upper one, what you'll get here is negative 1 half. So, that's negative of negative 1 half plus for this one sa baba, ang makukuha nyo dyan is 9 over 2. So, negative of negative 1 half, that's 1 half plus 9 over 2. So, 1 half plus 9 over 2 gives us 10 over 2, which is equal to 5. So, equals 5. So, that's it for letter C, no? Yung crucial part lang here, if you have absolute values, is learn to know kung ano yung gagamitin sa ating integral. If you will use this one or this one, and you also need to know kung ilang splits yung gagawin dun sa ating function. So, in this case, dalawang splits lang siya since isa lang naman yung breakpoint niya, which is negative 1. So, dalawang integrals lang yung naging result. Actually, there's another better way for this one, and this is by using the geometry nung ating function. So, pwede nyong tignan yung graph niya. So, basically, sinasabi nito, at x equals negative 1, 0 ka. And since yung nasa loob is x plus 1, yung graph natin is increasing as we go to the right. So, pag ganito siya, and let's visualize this hanggang x equals 2. Pagdating naman sa left side, since yung line natin is pag ganito, but we're taking the absolute value, i-reflect natin siya pataas. So, we reflect it here hanggang kay x equals negative 2. And since yung function natin is x plus 1, sure tayo na yung length nito is just the same as the height of this one. So, at x equals 2, this one should be 2 plus 1, which is 3. So, that's the value of y here. Then, if x equals negative 2, yung y natin would be negative 2 plus 1, which is negative 1. Pero absolute value, 1. Tapos, yung length nito, 3. Length nito, 1. So, what we have here are two right triangles. And yung area nito is 1 times 1 over 2. So, that's base times height over 2. We have 1 half. Tapos, yung sa kabila, nag-slide yung kamay ko. So, sa kabila, what we have here is 3 times 3 is 9 over 2. So, 9 over 2. Then, adding them both up, we have 1 half plus 9 over 2, which is 5. So, kung magaling kayo mag-visualize, you can integrate this using geometry instead of doing this quite long stuff. So, I hope letter C is quite clear. Oops. So, I hope it's quite clear. By this time, na-cover na natin lahat ng dapat i-cover based dun sa modules. However, just like what I told you sa discussion classes, magdadagdag ako ng extra na lesson. So, that's the definite integrals of symmetric functions. So, before we go to the actual integration, let's recall first yung mga ating symmetric functions. So, let f be any function. We say that this function is odd if kapag plinog natin yung negative x sa loob ng function na yun, it will just give you the negative of the actual function. So, f of negative x equals negative f of x. visually, ano yung appearance niya? So, suppose, ito yung graph niya sa positive side. So, ito yung graph niya sa positive side. If i-reflect mo siya to the left, para makita yung mga values of f of negative x, magmumukha siyang ganito. However, we said na f of negative x equals negative of f of x. So, this one, i-reflect natin pababa. That's why we get this graph here. So, basically, yung symmetry ng ating function is along a diagonal. Since this one, i-reflect mo ng pa-diagonal na paganito. So, ito yung ating axis of symmetry. Itong point na to, mapupunta doon. Tapos, itong point na to, mapupunta somewhere here. So on and so forth. So, yan yung ating odd functions. Second one is yung even function. So, a function f is even if f of negative x equals f of x. So, kung ano yung sa f of x, yun lang din yung sa negative x. So, for example, this is x equals 1. Tong value na to, matatagpuan mo rin sa x equals negative 1. So on and so forth. So, if you reflect that one, you get this side here. So, ano yung mapapansin natin sa graphs nila? So, let's consider a certain point sa sa kanan, say x equals a. So, this is x equals a. So, kung nag-exist ang x equals a, then nag-exist din yung x equals negative a. So, hanapin natin siya dito. This should be x equals negative a. So, sabi natin, no, symmetric yung function. So, tong portion na to ng graph and tong portion na to ng graph should be the same. So, kung ano yung area na to, yun din dapat tong area na to. So, ang tanong natin, what is the integral of this function from negative a to a? So, that's the area of this one plus the area of this one. So, tawagin natin yung area na to as a. So, if this area is a, what should be this area? So, tong area na to should also be a. However, pinag-uusapan natin dito is definite integral. And since nasa baba siya ng x-axis, sabi natin, we're taking the negative of this one. So, ang net signed area niyan is negative a. Pag pinag-add natin siya, negative a plus a, that's equal to 0. So, integral ng odd functions, kapag yung endpoints niya are just negative of each other, is equal to 0. So, integral from negative a to a of f of x dx equals 0. If it's odd. If it's even, kung even siya, this is x equals a, this is x equals negative a, same thing, pareho lang tong regions na to, but since they're both above the x-axis, pinag-a-add lang natin siya. A plus a equals 2a. So, integral of negative a to a of f of x dx could be expressed as this one, pero imumultiply mo lang by 2. So, that's integral of f of x dx from 0 to a. And that's our theorem here. Let f be continuous on the closed interval negative a to a. So, important to class, no? Para ma-apply natin yung symmetry, we want it to be from negative a to a. So, it should be the negative of each other. If f is even, the integral from negative a to a of f of x dx equals twice nito. Twice nung integral from 0 to a. Pero if f is odd, then integral of f of x dx from negative a to a equals 0. Let's try to prove this formally using yung ating properties ng definite integral para ma-practice na lang din yung knowledge nyo doon. So, let's start with the first statement. So, first statement tayo. So, if f is even, ano yung masasabi natin, class? If f is even, so by definition, f of negative x equals f of x. So, what we do, so you have here integral from negative a to a of f of x dx. Pwede natin siyang split sa gitna by x equals 0. Since, if you have here negative a, papunta kay a, kahit anong a yung ilagay mo, for example, a equals 100, kunwari. So, the other endpoint would be negative 100, and so, nasa gitna niya si 0. So, hatiin natin siya sa gitna by x equals 0. So, that's the integral from negative a to 0 of f of x dx plus the integral from 0 to a of f of x dx. And what we can do, since yung negative a is nasa baba, pwede nating pagpalitin yung bounds for integration, pero mag-i-introduce lang tayo ng negative sign dito. So, negative integral from 0 to negative a of f of x dx plus integral from 0 to a of f of x dx. So, dun sa theorem natin, meron na tayo nung part na to. However, paano natin palalabasin yung 2? So, let's manipulate tong part na to. And what we can do is try natin mag-use substitution. So, ito yung gusto kong galawin. For star, we try to let u to be equal to negative x. So, bakit negative x? Since we have this remark na f of negative x equals x. So, ilagay ko na lang din pala dito para mas maging clear yung nangyari. Palitan na natin siya to f of negative x. And this one is because of this one here. So, if we let u to be equal to negative x, then du natin would be negative 1 times dx, which is negative dx. Tapos, for the bounds, if x equals 0, yung u natin would be negative of 0, which is 0. Tapos, if x equals negative a, yung u natin becomes negative of negative a, which is a. So, we get here negative integral from 0 to u equals a of f of u times yung dx ay magiging negative du. Since if we multiply by negative 1, we get negative du equals dx. So that's negative du plus integral from 0 to a of f of x dx. Then this one would be equal to so may negative ka dito na pwede mong ilabas. So negative times negative is positive. So that's 0 to a f of u du plus integral from 0 to a of f of x dx. In this case, ibabalik pa ba natin si u? So, pag binalik natin si u, this becomes f of negative x. Tapos si du becomes negative dx. Tapos yung 0 here is still 0. Yung a here magiging negative a. So, bumalik lang tayo dito. And that's useless. However, let's try and see kung ano yung meron tayo dito. What we have here is the function f, pero ang variable natin is u. Dito, we have the function f, but the variable is x. So basically, we're looking at the same function. Kasi for example, if f of x equals x squared plus x, yung u natin here is just u squared plus u. So they're the same function. And if kukunin natin yung integrals nila, this becomes x cubed over 3 plus x squared over 2. This one becomes u cubed over 3 plus u squared over 2. So, they're still the same. Then, if i-plug natin si a dito, we get a cubed over 3 plus a squared over 2. Dito naman, a cubed over 3 plus a squared over 2. So, they're the same. If i-plug mo si 0, 0 to 0 to, 0 to 0 to. So, they're the same. So, basically, what I'm saying, tong dalawang integrals na to, they are just the same. Since ang pinagkaiba lang nila is yung letter. This one is u, this one is x, pero the bounds are the same. So, we're talking about the same integral here. So, we can just take yung u and palitan siya into x. And now, what we have is 2 times the integral from 0 to a of f of x dx. So, is this clear? So, basically, lumalabas dito na yung u is just a dummy variable. So, tawagin natin siya as a dummy variable. So, pag sinabi nating dummy variable, that means na iba yung variable niya compared dun sa gusto natin. But in essence, kung i-apply mo yung mathematics behind it, you're just getting the same result. That's why it's a dummy variable. So, pinalitan mo lang yung face niya, pero it's just the same thing as what you want to manipulate here, which is yung mga x. So, that's the first part. For the second part, ang meron tayo dun is yung case kapag yung function is odd. So, if f is odd, ano nga ulit siya by definition? If f is odd, f of negative x equals negative of f of x. So, yung integral from negative a to a of f of x dx, ulitin lang natin yung first part ng argument here. So, split natin siya at x equals 0. Then, apply a change of bounds. So, mag-a-apply lang tayo ng negative sign. So, we get here the negative of integral from 0 to negative a of f of x dx plus the integral from 0 to a of f of x dx. And what we do now is gamitin natin tong properties na to. So, if f of negative x equals negative f of x, we can say na yung negative ni f of negative x is just the same as f of x. So, yung f of x here, palitan natin nito. So, this one becomes negative from 0 to negative a of negative f of negative x dx plus integral from 0 to a of f of x dx. Meron kang negative here, so pwede mo siyang ilabas. Negative times negative would give you a positive. So that's 0 to negative a of f of negative x dx plus 0 to a f of x dx. Then same dun sa ginawa natin kanina, we do a u substitution. In particular, dito sa part na to, so if we let u to be equal to negative x, we get du to be equal to negative dx. Or alternatively, negative du equals dx. Then let's change the bounds. If x equals 0, yung u equals negative of 0, which is 0. Tapos, if x equals a, yung u would be the negative, if x equals negative a pala. If x equals negative a, then yung u is negative ni negative a, which is a. So, we get here integral from 0 to a of f of u times yung dx here becomes negative du. So, f of u times negative du plus integral from 0 to a of f of x dx. Since meron kang negative 1 here, pwede mo siyang ilabas. We get here negative integral from 0 to a of f of u du plus integral from 0 to a of f of x dx. And what we see here, same function f, magkaiba lang yung variable, x to, this is u, but we have the same bounds. So yung u acts once again as a dummy variable. So dummy variable. And so, this one is just the same as negative integral from 0 to a ng f of x dx plus integral from 0 to a of f of x dx. And negative of this one plus this one, that's just 0. So that proves our theorem here. So balikan natin yung theorem. If f is even, then the integral from negative a to a of f of x is just the twice nung integral from 0 to a. Tapos kung odd yung f, integral from negative a to a of f of x is just 0. So let's try the following examples. Number 1, find the integral of sine of x raised to 5 dx from negative pi to pi. So let's assume hindi natin alam yung theorem. So paano magiging approach natin dito? Since may x raised to 5 sa loob ng sine, ginagawa natin, we let u to be equal to x raised to 5. So yung dx natin is, du natin rather, is 5x raised to 4 dx. However, you don't have a factor of 5x raised to 4. So, u substitution would not do us any good. Pero, tignan natin yung bounds, no? Yung bounds natin is negative pi to positive pi. So, what we can do is check kung meron tayong symmetry na makikita. So, let small f of x to be equal to sine of x raised to 5. Then, to check for symmetry, ang ginagawa natin is we look at f of negative x, diba? So, f of negative x equals sine of negative x raised to 5. And this one is sine of, so since yung power natin here is odd, ang matitira sa loob is negative x raised to 5. And let's try to recall a property ng sine function. So sabi natin before, or sabi pala nung teacher nyo before, hindi ako. So, sabi nung teacher nyo before, sa Math 20 or sa pre-calculus nung high school, sine of negative x is just the same as the negative of sine of x. So, applying that property, we get here the negative of sine of x raised to 5. And sine of x raised to 5 here is exactly your f of x. So, that's negative f of x. So, napakita natin na f of negative x is just the same as negative f of x. So, this means na yung function f natin is odd. And kapag odd yung function, ano yung pwede nating gawin? If the function is odd, yung integral from negative a to a would just be 0. So, this one, integral from negative pi to pi of sine of x raised to 5 dx is just 0 since f is odd. Is this clear? So, kung gusto nyong i-double check kung tama yung sagot natin, hindi nyo kasi kayang kunin yung integral nito by hand. So, try to use an integral calculator kung gusto nyo siyang makita. So, let's proceed to the last example for today. So, we want to look at the integral of absolute value of x from negative 7 to 7. So, kung titignan natin yung bounds, they're just the negative of each other. So, why not check yung symmetry nito? So, let f of x to be equal to the absolute value of x. Ang gusto nating tignan is yung f of negative x. So, f of negative x equals the absolute value of negative x. And if we have absolute values, ang pwede nating gawin is ipaghiwalay yung mga factors niya. Since negative x is just negative 1 times x. So, by the property of absolute values, this is just the absolute value of negative 1 times the absolute value of x. Absolute value of negative 1 is 1, then multiplied by the absolute value of x. So, what we have here is absolute value of x, which is yung f of x natin mismo. So, napakita natin na f of negative x equals f of x. So, sinasabi nito, anong klaseng function si f? So, f of negative x equals f of x. That means f is even. Hence, tong integral na to, from negative 7 to 7 of absolute value of x dx becomes, by the theorem, nasan na si theorem? Nandito. It becomes twice the integral from 0 to a. So, it becomes twice the integral from 0 to 7 of absolute value of x dx. And dito sa bounds na to, so we're looking at non-negative bounds. So, pwede na nating i-remove yung absolute value na to because absolute value of x is x if x is greater than or equal to 0. Negative x if x is less than 0. Since the bounds are non-negative, ito yung gagamitin natin. So, it becomes 2 times 0 to 7 of absolute value of x dx. So, sulat ko na lang din here, no? X if x greater than or equal to 0. Negative x if x less than 0. So, we have 2 times the integral of x from 0 to 7. Or, basically, that's just 2 times x squared over 2 evaluated from x equals 0 to x equals 7. So that's 2 times 7 squared over 2 plus, ay minus 0 squared over 2, which is 0. So what we have is 2 times 7 squared is 49 over 2. Then, pwede na natin tong i-cancel out. We get here 49. So, yan yung integral of absolute value of x from negative 7 to 7. If you want to double check yung answer, you can go the long route na ginawa natin a while ago, where since ito yung definition ng absolute value of x, pwede mo siyang gawin as negative 7 to 0 of negative x dx plus 0 to 7 of x dx. But eventually, babagsak ka lang din dito if you apply the properties of definite integrals. So, that's it for our discussion sa 4.4. Just a reminder, sa Tuesday pala, that's June 6. So, sa Tuesday, it's our integration B. Please be here. Please be in the classroom by 8:35 para sa R9. Tapos para sa V1, be there by 11:35. Then for some exercises, if you want to practice more about definite integrals, you can check the following. So, Math 21 course module, yung TC7 ni Lighthold, Calculus by Stewart, Calculus by Larson. Magaganda yung exercises nila dyan. So, that's it for this video. Sorry kung lumagpas ako ng 1 hour, but I hope nakatulong yung discussion na to. And especially yung latter part, yung extra lesson, since if magte-take kayo ng subject sa engineering or sa physics, madalas na lumalabas yung mga symmetries. And that makes your integrals a lot simpler kung meron pa ng symmetry yung function. So, thank you everyone and see you on Tuesday.